Ever wonder how your favorite streaming service just knows what movie you'll love next? Or how a supermarket seems to lay out its aisles in a way that just makes sense? Well, it's not magic, it's data mining. And today, we're going to pull back the curtain on one of the classic algorithms that makes it all possible, a priori.
It really all boils down to this one question. What can a simple shopping cart really tell us? And the answer is, a whole lot. You see, the things people buy together aren't just random. They hold these hidden patterns, these little stories about our habits. And learning how to read those stories, well, that's a data superpower.
So there's a formal name for this kind of detective work: market basket analysis. It's all about sifting through literally millions of transactions to find these fascinating and often really profitable connections. You've probably heard the classic, though maybe not entirely true story about people buying diapers and beer together. That's exactly what this is all about.
So here's our game plan for this explainer. We're going to start with the simple core idea that makes this whole thing work. Then we'll walk through the algorithm step by step. We'll even take a peek at what it looks like in our code, and then zoom out to see where else this awesome tool gets used in the real world.
Okay, so how do you find these patterns without checking every single possible combination of items? I mean, that would take forever, right? Well, the secret sauce is a brilliantly simple idea called the A-Priori principle. But before we get to that, we need to get two key terms under our belt.
First up is support. The easiest way to think about support is just popularity. It's a simple count of how often an item or a group of items shows up across all the shopping carts. So if something has high support, it just means a lot of people are buying it. Simple as that.
And number two is confidence. Now, this is all about predictive power. If we think we've found a rule, like if someone buys coffee, they also buy sugar, confidence tells us how likely that is to be true. It's the probability that if we see coffee in the cart, we're also going to find sugar right there with it.
And that brings us to the main event, the a priori principle. It says this: if a group of items is popular, then any smaller group you can make from it must also be popular. So, if bread, milk, eggs is a frequent combo, then bread, milk has to be too. But here's the real magic, the reverse. If we find out that, say, bread butter is not popular, well, then we know for a fact that any bigger combination that includes bread and butter, like bread butter jam, has absolutely no chance of being popular. This lets us just throw out millions of possibilities without ever having to check them.
So this amazing principle gives the algorithm this elegant little two-step dance it does over and over. It's called join and prune. It works its way up, starting with individual items and getting bigger, using that principle to slash the search space at every single step. This is the cycle that runs the whole show. First, you join the popular item sets you already found to create slightly bigger new candidates. Then you prune. You just chop off all the new candidates that you know can't possibly be popular. Let's see exactly what that looks like. Okay, we start at square one. The algorithm just zips through all the data one time and counts every single individual item. So as you can see here, item 1 showed up in 6 carts, item 2 was in 8, and so on. Now we apply our first prune. We have to set a threshold. Let's say we only care about things that appeared at least 3 times. Anything less, we're just not interested. So boom, we throw out items 3, 5, 6, and 7. What's left over is our list of frequent one-item sets, which we'll call L1.
And now for the join step. We take the survivors from that last round, I1, I2, and I4, and we combine them to create every possible pair. These are our new candidates for level 2, and we'll call this list C2.
And what do we do next? We do it all over again. We scan the data a second time, but this time we only count our new candidate pairs. Turns out all 3 of them meet our minimum support of 3, so they all make the cut and become our frequent 2-item set list L2. The algorithm would then try to join these to make 3-item sets, and the whole cycle just keeps on going until there's nothing left to find. See how elegant that is? Join and prune.
So that's the theory, and it makes sense when you see it laid out like that. But what does this actually look like when you sit down to write some code? Let's take a quick peek at how this is implemented in the R programming language.
And the code and concepts we're going to look at here are drawn from an awesome book by Bader Makabel called Learning Data Mining with R. It's a great resource if you want to get your hands dirty with this stuff.
Now you don't need to be an R expert to see the beauty here. Just look right in the middle, at that while loop. That's it. That's the engine of the entire algorithm we just described. It's basically telling the computer, hey, keep doing that join and prune cycle, level by level, for as long as you keep finding new popular stuff. It is the exact process we just visualized, but now it's captured in code.
Market basket analysis is the classic example, but the power of finding frequent patterns goes way, way beyond the grocery store.
I mean, think about it. This same logic is used to analyze your clicks on a website to figure out what you're doing. It powers recommendation engines everywhere. It's even used in bioinformatics to find patterns in super complex genetic data. And it can track medical treatments to see what works, or even help prevent disasters by spotting common warning signs.
And of course, a priori isn't the only game in town. A really popular alternative is an algorithm called ECLAT. Now, where a priori reads the data like we do, row by row, ECLAT flips it on its side. It looks at each item first and lists every single transaction it's in. And for some types of data, that vertical approach can be a whole lot faster. It just goes to show you how rich this field really is.
So, the next time you get a recommendation that feels almost too perfect, or you see a product placement that just makes sense, you can think back to the simple, powerful logic of a priori. Which really leaves us with one final thought to chew on. What hidden patterns and associations are shaping your digital world right now?